Decided to make a quick video for any of you that have difficulty on continuity and differentiability. Okay, so I came up with a scenario that's as follows. A vehicle under testing is made to accelerate towards a wall in order to determine how well it can handle impact. The vehicle accelerates at 15 miles per hour per second for 10 seconds. So what that means is the vehicle, for each second, the vehicle increases its speed by 15 miles per hour. Okay. So it accelerates for 10 seconds until it reaches its maximum velocity of 150 miles per hour. A timer is started as soon as the vehicle reaches its top speed. The vehicle remains at its top speed for another 7 seconds, then finally impacts the wall and coming to a stop in 2 seconds. Do not mind these two functions there, they are wrong. So the question asks us to plot the graph of this function, then determine if it is continuous or differentiable for values of t that are members of the set of real numbers and range from -10 to 9 to +9. Okay, so this is our function here and this is our graph. So our function is v of t, so it's a function of velocity. I use v for velocity, and time is t, right? Okay, so that's a piecewise function. So what that says is for -10 to when the time is in the range of -10 to 0, because remember the statement said that they start the timer after it reached maximum velocity. So you have to account for the time before they start the timer. So the time when they start the timer, that's 0 seconds. So the 10 seconds before that, we assign them a negative value, so -10. Okay, so for this, we can see that it was accelerating. That's a speed. We can see that the speed increases with time. So the function we use for that is 15 open brackets t plus 10 close brackets, and that's the interval when t is in the range from -10 to 0, but it doesn't include 0. That's an open interval there. Okay, so for the range of t from 0 to 7, that's this portion there, our function is 150, a constant. V of t is equal to 150. That's that constant. And finally, for the range of t between 7 and 9, including the 9, it's 150 minus 75 on 2, in brackets t minus 7 squared. And this is a quadratic function. Now first we are going to check to see if the function is continuous. Now looking at the function, we can do this two ways. We can do this by looking at the function, and we can do it with our piecewise function mathematically. Okay, so now looking at the function here, right, it's obvious that it's continuous. It goes, there is no breaks, right? There are no breaks. If you look at what value the function approaches from the left, we can see that it approaches the same value as when it comes from the right, when t is 0. For it to put my 0 there. Okay, and the same thing for this part there, when it's continuous, because the function value is the same as the limit when it comes from both the left and the right. So it's obviously it's continuous, but when you're doing the math, we have to prove that. Okay, so first we're going to check to see if the function is continuous at t is equal to 0 using mathematics. So for a function to be continuous, we know that it must possess a limit. And for it to possess a limit, the limit as t approaches that value, which is 0, from the left should be the same as the limit as t approaches that value. The limit of our function, sorry, as t approaches 0 from the right. And we can see that when you get closer and closer and closer to 0, our limit is 150, and that's from the left. And from the right, when you get closer and closer to 0, we are approaching 150. So the limit as x approaches 0, as t approaches 0, of v of t is 150, and it exists. Now from our piecewise function, we know that v of 0 exists. That's a second function, that's where 0 is included. So v of 0 is 150. So the limit as t approaches 0 of v of t is 150, and v of t, and v of t at t is equal to 0 is 150. So that means it must be continuous. So here's the working I have there. So first I found the limit as t approaches 0, the limit of v of t as t approaches 0 from the left. And I said that is equal to the limit of, since we're approaching from the left, we have to use the first function. That's 15 by t plus 10, right, as t approaches 0. And then we do direct substitution, because we cannot work with that anymore. Direct substitution basically substitute t for 0. So when we do that, we get 15 by 0 plus 10, which is 15 times 10, which is 150. Now, we also do the limit when approaching from the right. So the limit of v of t as t approaches 0 from the right, that is equal to the limit as t approaches 0 of 150. That's a function that we use because we come in from the right. So that is equal to 150, because the limit of a constant is a constant. So that means since the limit when you come from the left and the right is 150, they are the same. It means that the limit as t approaches 0 of v of t exists, and that value is 150. So we also need to know that there is a function value at v of 0. There is a function value of v of 0. If there is not a function value, it's obvious that it's not continuous. Right, so we check for v of 0. That's the let me see, that's this question, because 0 is included in this one, so that's 150. So v of 0 is 150, right? So that, and 150 is equal to the limit as well. So because the function value is equal to a limit, we can say that it's continuous at t is equal to 0, because it fulfills all the requirements needed to say that the function is continuous. Okay, so now to check for continuity at t is equal to 7. So same thing, let's do the graph first. We need to know if there is a limit, if the limit exists when t approaches 7. So to do that, we check from the left and from the right, and if they have the same values, we know that the limit exists. So the limit of v of t when t approaches 7, get closer and closer to 7, we can see that v of t gets closer and closer to 150. Well, it is 150 always, so it doesn't matter. That's from the left, and from the right, when t gets closer and closer and closer to 7, we can see that v of t gets closer and closer to 150. So both of them, from the left and the right, has the same limit, so that means the limit exists. Mathematically, we have the limit of v of t as t approaches 7 from the left. So since we're coming from the left, we have to use the function v of t is equal to 150. So that's a limit of 150 as t approaches 7. Since that's a constant, then the limit has to be that constant. That's a limit theorem. That's one limit theorem right there. The limit of a constant is that constant. Okay, so We're doing from the right this time. So the limit of v of t as t approaches 7 from the right is equal to, we're using that function because we're coming from the right, the limit as t approaches 7 of 150 minus 75 on 2 by t minus 7 squared. So runtime, we can use direct substitution, right? Actually, this to that is not allowed. You actually have to go through the steps through the theorems that you use. But anyways, it's just for understanding sake. But yes, so we just use direct substitution, replace the t with 7. That's what we have there. We get 150 minus 75 on 2 by 7 minus 7 squared. 7 minus 7 is also obviously 0. 0 squared is 0. 0 times anything is 0. 150 minus 0 is 150. So now we can see that the limit from the right and from the left is the same 150, so the limit exists. Now we need to check v of 7 as well. So that's the limit of v of t as t approaches 7. That's 150. So we need to check v of 7 as well. V of 7, since 7 is included in the second part of the piecewise function, that's 150. So v of 7 is 150. So since v of 7 is the same as the limit, we can say it's continuous at t is equal to 7. It's that simple. Now when you're looking at a graph for differentiability, well, is it differentiable for a certain point, right? What you need to look at is just to check to see, is there any point where you see a sudden change in the gradient? If you see a sudden change in the gradient, automatically it makes it not differentiable. Also, you must also check to see if it's continuous, because if it's not continuous, then there's no way it can be differentiable. But if, as we can see, these 2 points were continuous, but now we're checking to see if it's differentiable. So all we need to look is to see if there is a sudden change in the gradient. Look at this one. Here we have a nice semi-steep gradient, right? Our gradient is steep, or semi-steep, until you reach that point, and then it just gets flat. That's a sudden change in the gradient. And that change didn't even take time to happen. It took 0 time for that change. You going like this, and all of a sudden you just end up like this. So when you see that scenario, that means it's not differentiable. So you look at, in order to determine it's differentiable mathematically, you look at what happens to the gradient as it gets closer and closer to that value, which is 0, whatever value you're interested in. As it gets closer and closer to that, what is happening from the left? From the left, it is the gradient of that function. And from the right, it's the gradient of that function. Now the gradient of that function is 0, because the gradient of any constant line is 0. But the gradient of this one is actually 15, because this is a linear equation, and this has to be, it's in the form of y is equal to mx plus c, but since we have v and t, it's the form of v is equal to mt plus c, and 15 is obviously m, so 15 is a gradient there. So here the gradient is 15, and here the gradient is 0. So when you're looking at the gradient when you're coming from the right, it's 0. When you're looking at the gradient when you're coming from the left, it is 15. So if I ask you what's the gradient at that point, then it's easy for somebody to say it's 15, because they're looking at from that perspective, and it's easy for somebody else to say it's 0, because they're looking from that perspective. So if I ask you what's the gradient of that point, you cannot say that it's not 15 and it's not 0. 0 and 15 makes sense, but the gradient cannot be both. The gradient has to be one value. So because this scenario, which contradicts, one says 15 and one says 0, exists, we will say that this is not differentiable. because at this point we have two different gradients. Notice at this point we just have one gradient, and at this point we just have one gradient, but this point we have this gradient and this gradient. Now for this point there, I did some injustice. Well, in terms of the drawing, we know that it looks as if it's drawn to scale, but it's not drawn to scale, just me, because this one looks as though there is a sharp change in gradient, but the truth of the matter, it's not. What this should look like is, let me zoom. Yes, so what this should look like is this. So nice, make it focus, a nice straight line here, and then it just changes, right? The gradient not changes, but it's a nice straight line, and then it goes down. It's not supposed to look like that rough change, just nice and straight, and then it slightly goes down. Right. This part there is actually differentiable. This point there is actually differentiable, because when you look at the gradient, what happens to the gradient when it gets closer and closer to that point? Let's say that point is 7 there, right? Okay, that's the gradient here, then that's the gradient there, and then when you get closer and closer to 7, you realize that it gets closer and closer to 0. Same for there. When you get closer and closer to 7 from the left, it stays the same 0. So the gradient from both sides, when you approach from both sides, is 0. So that means it's differentiable. But we will look at the math for that right now. Okay, so we're looking at if the point is differentiable at t is equal to 0. This point there, at t is equal to 0, if it's differentiable, right? So as we said, we look at what happens to the gradient. The gradient is v prime t from the left, and look at what happens to the gradient from the right as well, which is this part there. Now this seems confusing and it seems that I got it from nowhere, but this is actually the equation of gradient. Remember, gradient is equal to, let me write it there, y2 minus y1 over x2 minus x1. So what this is actually, it's this part there is y2, but since you want to get closer and closer to 0, instead of actually having a value for this point there, we leave it as the equation. And this one there is y1. Y1 is v of 0. And this one is x2, which is t, minus, and this one is x1. So that's a formula for the gradient. And the reason why we had to leave t there, because we want to see what happens. Let's say, since we're coming from the left, we want to see what happens to the gradient when you get closer. So we're looking at that gradient. So first we're looking at that gradient and the gradient between these 2 points, right? And then look at these 2 points, and then look at these 2 points, and you get closer and closer and closer. If we just make it 1 point and we just take its y value, and it's, well, not y value, it's v of t value, and its t value, then we will not be able to see what happens when it gets closer and closer. So we have to leave it as a variable so we can account for the changes. Okay, so yes, so that's that. As the equation we use y2 minus y1 over x2 minus x1, and that is equal to, we use distributive law there, 15t plus 150 minus 150, because v of 0 is 150, and t minus 0 is obviously t. Right, so 150 minus 150, that'll cancel out to give us 0. All we are left with is 15t over t. Right, and then we must not use direct substitution. So that's another limit theorem there. We shouldn't use direct substitution for this one, because if I use direct substitution and I say that's 15 by 0 divided by 0, we'll get 0 divided by 0. And 0 divided by 0 is undefined. Because the truth of the matter is, we can only use direct substitution. Is not ideal. Because they're not asking you for what's the value at 0. They're asking you what happens when you get closer and closer to 0. They never ask you to reach 0. They just ask you to say, what are you approaching when you get closer and closer to 0? So, in actually, t is never 0, but t can be 0.0001 or 0.00000009 or something close to 0 but not 0. And because it's not 0, whatever number that is there, it can cancel out that number there. If this was 0, you would not be able to cancel them out. But since it's not 0, but it's something close to 0, whatever number you put that's close to 0 here and here, it will cancel out the 2. So you'll get 15 in return. So you have to make sure you simplify. When you're doing limits, you need to make sure you simplify the functions as well, the equation as much as possible. And after you finish simplify, then you can use direct substitution. All this to say, when you approach from the left, the gradient is 15, which is the gradient of this line there. This part there, that's it. Now, when you approach from the right of our gradient v prime t, so we're using the function 150. So the limit is equal to 150, that's y2 minus v of 0, which is y1, over x2, that is t, minus x1, which is 0. Okay, so that is equal to the limit of 150 minus 150 as t approaches over t, as t approaches 0. And then when you simplify that, that's 0 over t. We do not use direct substitution because we can simplify further. So 0 divided by anything is 0. So that's the limit of 0 as t approaches 0, which is obviously 0. Right. So when you look at the gradient, what happens to the gradient when you're coming from the right, and we look at the gradient when you're coming from the left, we can see that this one gives us 0 and this one gives us 15. So obviously at that point we can argue that there are two different gradients, and because there are two different gradients, we can see that it's not differentiable. There must be only one gradient for every point. It's not differentiable because from the left it's not equal from the right. Okay. Now to check for differentiability at t is equal to 7. Right, same process. We look at what happens to the gradient when you come from the left, what happens to the gradient when you come from the right. So when you come in from the left, that is equal to the limit of 150 minus v of 7 over t minus 7 as t approaches 7, right? y2 minus y1 over x2 minus x1. So that is equal to this, which is 150 minus 150 over t minus 7. 150 minus 150 is 0. 0 over t minus 7. 0 divided by anything is 0. The limit of 0 is 0. Now, from the right this time, the limit of the gradient of v of t as t approaches 7 from the right. So that is equal to, we use the final function. So 150 minus 75 over 2 by t minus 7 squared minus v of 7 over t minus 7. Because the 2 points are t and v of t. V of t is this one. And our second point, that's the second point, is 7 and v of 7. So we subtract the 2. The y coordinates and x coordinates. So when you simplify that, we know that v of 7 is 150. We can see that from our piecewise function. So we just put the 150 there. 150 minus 150 will cancel out. So we have minus 75 over 2 by t minus 7 on 2. T minus 7 squared, sorry, divided by t minus 7. And then when you simplify this, you can see that we can cancel out this and this. Or we can cross out because that's t minus 7 divided by t minus 7 squared. So let's take out one of them. So we get the limit of minus 75 over 2 by t minus 7 as t approaches 7. So now we cannot simplify this anymore. We basically cannot get rid of any more t's. So the only thing left to do is use direct substitution. So we will substitute the 7 for the t. So you get 7 minus 7. 7 minus 7 is 0. 0 times anything is 0. Right? The explanation is at the top. Okay, so since the limit of the gradient as t approaches 7 from the left is equal to a limit of the gradient of v of t as t approaches 7 from the right, since they are equal to 0, both of them are equal to 0, then we can say that, and also v of t is continuous at that point, we can say that v of t is differentiable at t is equal to 7. Thank you guys. Hope you enjoyed this one.